Hi and welcome to this video for the BTEC Applied Science Level 3, Unit 19. So again, we're within the first assignment brief and it's a practical where what we'll be doing is looking at trying to work out the sodium bicarbonate concentration within water. So all tap water has these ions floating about within them. Uh, Generally, they don't do you any harm, part and parcel of flowing through pipes and things. So within this practical, the first thing we'll be doing is using some sodium carbonate to standardize our hydrochloric acid, and then we'll be reacting this hydrochloric acid whose concentration we will have now worked out to determine the amount of sodium hydrogen carbonate or sodium bicarbonate present. So as we can see from the practical, first off, hydrochloric acid is going in the burette and we are getting some sodium carbonate. We are pipetting 25 cubic centimeters of the sodium carbonate into a conical flask at the start. And then we'll do the titration using the bromophenol blue indicator to see when the color change occurs. Right, so just to make up some results, we'll say 23.10. As usual, with a rough, you've probably overshot it, so we'll say a little bit less, and then we'll say I filled it up, didn't get exactly to the start. So concordant results straight away again, just to save me writing a third. The average of these. And there. And now this is what we'll be using for some of the calculations to come. So first off, we need a balanced equation. We need to know the molar ratio that these two react with each other. So we've got the sodium carbonate. So acid plus carbonate, we are going to get metal salt, carbon dioxide, and water. Just a case of balancing it now. Two sodiums, need two sodiums there, two chlorides, so two here, and everything else looks fine. So calculate the number of moles in 25 cubic centimeters of your 0.05 molar sodium carbonate solution. So equation, N equals CV. Concentration, given here, so capital M is moles per decimeter cubed, molarity. So we've got 0.05 times volume here. Again, cm cubed, convert to dm cubed. So calculator wise, 1.25 times 10 to the minus 3. Now, using your balanced equation, calculate the number of moles of hydrochloric acid neutralized. So we've got a 1 to 2 ratio up here. So for every 1 mole here, we'd be neutralizing 2 moles. So all I need to do is that there. So multiplying it by 2, 1 to 2 ratio. Now, using your answer here, so this one, so our number of moles, and your average of your concordant result to calculate the concentration of hydrochloric acid. So I need N equals CV again, since we're looking at a solution. Rearrange C equals N over V. So my number of moles, 2.5 times 10 to the minus 3, divided by volume, we had 22.475. Over 1,000 to convert to dm cubed. If we get the calculator and type that in, So concentration 0.111 to 3 significant figures moles per decimeter cubed.